Oh, we're going.
Yes.
Sylvia, welcome to the first episode of the Mars vlog.
Thank you, Gaber. It's great to be here.
It's super great to be here. I've had the most complicated day.
Yeah.
Yeah. Hey, we've had some big changes, and I think that's what inspired us to actually start this thing.
Yeah.
And what's our goal here with the Mars vlog?
So the Mars vlog is going to be a set of videos that we'll release weekly or bi-weekly. Haven't figured that out yet. But the goal is that people are able to stay updated with what's going on with the project, and that it's an opportunity to have an onboarding path for potential team members.
Right, because we're looking to expand the team outside of the physical boundaries of our current Mars effort, which is, other than one other person, kind of largely located right here, right?
Yeah.
And part of what I really love about this is we're kind of poking at the edges of how do we open those doors completely and let everybody who wants to play on Mars come in. But I think just for the sake of our audience, there's a lot about that we're still trying to figure out.
Yeah.
And this is just the beginning, and every episode we'll probably have a little bit more figured out of how that's going to work.
Exactly.
All right. How about if we start with leading up to the big recent change?
Yeah. So in 2020, we built Mars, the Chabot lava tube, and it took 6 weeks to build a lava tube that filled up about 1,500 square feet. And can you go to the next slide? It was a full simulation of what it's like to be on Mars and theoretically what it would be like inside of a Martian lava tube.
Yeah, one of the things that I think is so amazing about this thing is it's built like a movie set. It's designed to be seen from the perspective of the rover.
Yeah.
So as we look at it as full-grown people, we see a lot of things where, oh, the sky is just a plastic tarp. But we actually designed the sky so that it would be bright enough to blow out the camera and achieve just a blank sort of off-white sky. Yeah.
Exactly. We had our rovers in there.
And what I loved about what this place really accomplished was it felt like Mars when you looked at it through the eye of the rover. And so the world was scaled to this size so that this felt like you were driving a big piece of industrial equipment on Mars.
Exactly.
Yeah. But then
we decided to move out because of a number of reasons, namely that we didn't want to stay in the same location we were in. We decided to deconstruct the lava tube 2 weeks ago and move the manufacturing station into the building with the rest of the Institute for Applied Tinkering in the Presidio. So
Can I add one thing?
Yeah.
What I love about this shot is it's almost like a reverse time lapse of how we built it.
Yeah.
And one of our team members, Owen, had started to build this cave section just in a fit of we're talking so much, we're not getting anywhere. And I think over a weekend or something, he just hauled off and started building it. And we came in and we were like, right.
Exactly. That's exactly what needed to happen.
Yeah. And what I love here is the chair that's in here that gives you a sense of what that space, how it was scaled and what it was like.
Yeah.
But then
now we're in the Presidio.
Yeah, so we moved not just Mars, but we moved Brightworks, the school where we were hosting Mars, and Tinkering School, the sort of part of the organization that Mars ran under, here into this beautiful building in the Presidio, which is our new forever home for all the programs.
Yeah.
But not necessarily the future, and in point of fact, absolutely not the location for the next Mars.
Exactly.
Yeah.
So what we're doing is building out the manufacturing area, which is where we have our prototyping and building going on. We don't have a Mars simulation in this building.
Right.
And
we don't, in fact, have a working Mars simulation anywhere.
Yeah, but I was just working all of today, putting up some shelves in the back and that backboard, which we'll put a tool wall on, and then we'll have some workstations in there and kind of contain it so that you're entering Mars just like it used to be.
Entering Mars manufacturing.
Entering Mars manufacturing. Yeah. Entering Mars is in the mindset of the project.
Right.
Yeah.
Right. Which is a big part of how we've designed the build area, the kind of R&D effort.
Yeah.
And in fact, the physical space is constantly reminding us of that perspective. Like, we're working on something that is a model of what NASA is doing.
Yeah.
And so there's a lot we do in the language, in the, like, calling it manufacturing, talking about the generations of the rover in a way that's very similar to how spacecraft are developed.
Yeah.
Yeah. It's part of the analog mission mindset, I feel like. Yeah.
Yeah.
Next slide.
Next slide.
So what happened recently?
This past weekend, we were part of the Tinkerfest at Chabot Space and Science Center, which is here in the Bay Area. And we ran the Wheel Lab, which is a workshop that we first designed for the Exploratorium, but basically where people have these wheel sleds, and this isn't one of the ones we use this weekend, it's an earlier generation, but has a wheel that you build off of, and you make a wheel out of commonly available tinkering materials like straws and cardboard, and then you drive it in a simulation of like Martian regolith. So we had some basalt lava and I think some coarser grain too that allowed visitors to prototype their own wheel design and then come back to it and just kind of make something awesome.
Yeah.
Yeah.
This exhibit, hands-on exhibit, was part of Tinkerfest, and one of the things that the Chabot staff noticed was it was super sticky. Yeah. The kids were, and families really, were coming in, getting caught up in what is a kind of like rapid prototyping work mode and staying for 45 minutes.
Yeah.
Like keeping going. And we were running out of sleds for new people who were walking up, and we had a line of people waiting for sleds to be freed up.
Yeah.
Yeah.
And one of the things I think is really valuable about this whole workshop we did is that people had never considered what makes a good Mars rover wheel before.
Right.
But as soon as you ask them, hey, what does it take to drive a rover on Mars, and what do the wheels need to be like to support that? Yeah. They just start thinking about a question that they've never really considered before. And then they're able to work through it, through this, however long they stay.
Yeah.
And they kind of come to an understanding of what makes a good Mars wheel.
Yeah. Hey, Sylvia, we have a special guest today who is part of the Mars team and who was there this weekend since neither of us really were.
Yeah.
Aiden, I wonder if you could step on stage here.
Yeah.
Up at the Mars vlog broadcasting studio / Anthony's office.
Yeah.
Aiden, what do you remember from this weekend that stands out in your memory?
I think the thing that I remember the most from this weekend was like how we had kids that would go and try a design that they saw everyone else try, and then they would realize that there was problems with it, and they would come back and keep iterating. We had so many kids that came back and iterated 5+ times and kept trying their ideas and like making them better each time, and it was so amazing to see all this like iteration happening so quickly in this environment.
Just to bring this back to our own experience on Mars before Aiden joined us.
Yeah.
Sylvia, how many iterations of the Mars wheel have you personally participated in? Just roughly.
More than 20?
Yeah.
Yeah.
More than 20. And it turns out this is one of the great things about the wheel problem is this has been a consistent, persistent area of development for NASA.
Yeah, and so even actually as we looked at the transition from doing most of the Mars science on Curiosity to Perseverance, we had been following along with Curiosity and noticed how the scientists were really concerned at all the holes in the wheels. And on Perseverance, they designed the wheels pretty similarly, but with some very significant differences that they think would really reduce those holes. And so far it's worked, but we're only a year, 2 years into the mission.
Yeah, but by this time in Curiosity's mission, we already had significant...
fatal holes.
Yeah, yeah. And one of the wheels, I can't remember which one, they're starting to plan their movements to reduce impact on that wheel.
Yeah.
Like,
Yeah.
yeah, like imagine that. Like, I'm going to drive my car, but I'm going to remember that the right front wheel is just on the verge of exploding. So I'm not going to run it over any bumps.
Yeah.
Yeah, it's a strange mindset.
Yeah.
Should we move on?
Let's move on.
All right. Right.
These are some of the pictures of
Yeah.
wheels.
Aiden, what do you see in this generation of somebody's experiment?
Yeah, so we saw these like very specifically at the museum. We saw these like waves of iteration where somebody would come up with an idea that worked really well, and this was one that definitely stuck out. Was this like spikes? Was adding little
Toothpicks?
like toothpicks or even like chopsticks to your wheels, and that worked really well for digging into the lava rock that
But
we
I
had.
saw one early iteration of that tear a wheel off because the straw had managed to penetrate the rubble and get down a few inches,
Wow.
and the motor had enough leverage to take the shaft out of the hub.
Of the
Wow.
wheel sled?
Yeah,
Wow.
yeah, because the gear motors
Right.
just have that adapter shaft is pressure fit onto a metal shaft. And
It's
that's-
actually a plastic shaft.
Yeah,
Yeah. And then I think Liam has some screw in there, but it's probably not doing very much.
well,
I think.
it seemed to work for the rest of the day. It was just
Okay.
a lucky one in
Yeah.
1,000. Yeah,
We had one of those during building them too, where one of the like shafts just exploded.
Yeah.
Yeah.
yeah. How about we noticed there were a couple of shots of these rovers with like long arms. How did they do?
Yeah, those ones seem to be very interesting because we had some where people were adding straws that were really long, and what they soon learned was that the longer they made the straws, the slower it went and the harder the motors had to turn because there was a lot more there was less mechanical advantage.
Yeah.
So then we had this one that was created. We had a Boy Scout that came in and developed this really interesting pattern using cardboard and tape to make it really strong.
Yeah.
And that size seemed to work really well.
Did it kind of walk along as the two arms would come out of sync?
He
I
knows
mean, they wouldn't come out of
they're
sync.
they're together.
Right, because we're
Oh,
just
because it's
using
a
one
single
motor. Yeah.
continuous output shaft. Yeah. Oh, interesting. Right.
Yeah.
So you could have them at 90 degrees to each other,
And they would just wobble.
or you could,
Yeah.
in this photo, they're aligned.
Yeah.
Yeah, and so many interesting trade-offs and details.
Yeah.
Speaking of which, I just wanted to highlight Liam's work moving from this earlier prototype to the one we delivered at Chabot, and then the fact that as he came back from Chabot, Liam had all these ideas about improvements for the next generation of the sled.
Yeah.
Yeah.
And notably, people bought the extra ones that we'd produced to sell, and all of the extra ones that we had made for just running the workshop.
Right.
Yeah.
They
Yeah.
were pretty beat up by the end of the day.
People
still
still
wanted
wanted
to
them.
buy them.
Yeah, yeah. So it's something that we hope to offer in our Mars store,
Yeah.
which is an upcoming project that we call the Chandlery.
Yes.
Yeah, which if anybody wants to talk about old nautical terminology, I'll help you out with that. Next up,
So Patrick, who's a newer team member of Mars,
we're talking about Generation 3 now, which is the replacement for the old workhorse Generation 1.5. And Generation 2 was a beautiful fantasy, and we built one of them and realized
it sucked.
this is not going to work.
Yeah. Well, yeah.
So
we learned a ton from it, though.
Yeah, we'll talk about it in a future episode.
That's a
because
great
I think
idea.
there's a lot to admire in Generation 2, and it taught us a lot about where we needed to go.
It bit off a lot.
Yeah.
Yeah.
But it had this problem we call the cram jam,
Yes.
and
The cram jam led us to realize that we could just make our own PCB and
Yeah.
eliminate a ton of the wiring that was getting in the way of actually having a rover that was small enough to fit in our scale lava tube. These ones are actually much bigger than they should be in
Right.
scale, and so we've always been trying to downsize. And with the Generation 3 rover, we're adding some functionality that we didn't have in the Gen 1s because we're doing better motor control we're doing stepper control instead of servos.
yeah.
So what you're looking at here is a 3D mock-up of what the PCB is going to look like. We've been really lucky to work with one of Gaber's old friends, Bob, who is an electrical engineer who does this
Yeah.
as his job, and he put together all the footprints for us, and then Patrick and I have worked on what the best layout is going to be. Note here that the motor connectors are towards the edges of the board so that we can put this right inside of the chassis and then have the wires come in, and then also that we have the pins in the middle so we can have an umbilical cord going out to the battery or out to whatever peripherals we need.
Yeah, and I mean, this is a first, I mean, this is a couple of iterations in, but it's the first full component layout we've tried, and we already have some notes about it, and it's just a fascinating new stage in the development of the rovers because it gets us away from the jumper wire problem that we had in this generation where vibration could cause us to have hard to diagnose issues with a given rover that we would only fix by just rewiring it again. It was horrible. Although I have to say, I've liked just picking this up. I have so much nostalgic goodwill towards this workhorse. We beat these up with week after week of summer camp.
I probably fixed each one several times.
And they've been like, now that they've kind of stabilized, they've been so durable. It's worthy of respect. It's
inspiring.
Yeah.
Raspberry Pi is doing something really great.
So talk to us about where we're going format, chassis wise. In Gen 3.
So I did some early mock-ups of what that size PCB that Patrick had made would look like inside the rover. We realized, an idea that we've introduced with Gen 3 is having the motors parallel to the control layer as opposed to underneath the control layer. And this means that we have something that's a little bit wider, but also something that's shorter overall, and that we gain extra clearance because we're not putting something underneath it.
Right.
So what you're looking at here on the top is that parallel layout, but what we realized when doing this is that the wheels are actually in a rectangle that's longer on the front of the rover, and
it's like wider than it is long.
Wider than it is long, which isn't ideal.
It's a strange shape for a vehicle, for a four-wheeled vehicle.
Yeah. So, but this led us to realize maybe we should move the PCB components around so that we can get something longer and skinnier and have them still be parallel, or stick the motors underneath. We really haven't come to any conclusion on what's best yet, but those are what we're experimenting with. And then down there is one of the Gen 1 rovers for scale. You can see it's 160 millimeters outside to outside, and then it's about comparable to the outside to outside of the Gen 3 with the motors in parallel. And
I think what one of the realizations we had for this one is the footprint of the wheels is a square, or it's really close to being a square. And the long, high aspect ratio rectangle of the chassis, we're kind of headed back in that direction with Gen 3, I'd say.
I agree.
And another thing I wanted to say, and that is a great thrill for us, is to start sharing excerpts from our Discord, which is so active and productive, right? And it's sort of behind the scenes, but so much of Mars is like, to use the iceberg metaphor, we have this kind of charismatic stuff happening up here above the waterline, but some of the most interesting stuff is happening behind and down below the waterline, behind the scenes, I meant to say. So one of our next initiatives is to work on some new branding.
So the Petra logo, which was developed in 2020 for the Petra mission, which was the program we ran
in the summer camp.
We're trying to adapt it to make something that's more neutral to the Tinkering School Mars mission programs. And these are some ideas that have been come up with by Alex and Patrick in the last few days.
And what primarily inspired us to rework the logo?
Well, kind of the comical thing is that we want new t-shirts. So this is one of the older t-shirts from 2020. It has the Petra logo on it.
Which we love.
Which we really love.
Anna drew it by hand, and
it's beautiful.
Yeah.
And we would like to have something that's more up to date to both wear on our equipment and put onto briefings and documents
Yeah.
and like have new stickers and that kind of thing.
And Petra was a element of a narrative structure that was the adventure of that summer camp.
Mm-hmm.
And our offering is no longer built around that exact narrative.
Yeah.
We're built more around NASA's training efforts for bringing people online to rover driving on Mars,
Yeah.
right? And that's in support of our new initiative, which is to bring Mars to classrooms.
Yeah.
And so that's the thing that fueled the whole logo redesign retreatment.
Yeah.
And our team member Alex took the branding guidelines from Tinkering School, which is the official trademarked registered guidelines and all of the things about contrasting color and all of that,
Yeah.
and brought us back a logo that's like can work for multiple purposes and fits in a lot of different contexts.
Yeah.
Yeah, very excited.
Me too.
Looks really good.
And this is a little peek into Patrick and Alex's conversation about
Yeah.
various treatments. And one of the ones that I think is so interesting is this one in the lower third of the screen here, which gives this lovely hint of Mars in a much more, it's in a certain sense, it's like closer than
Yeah.
you expect it to be.
You're getting onto the surface.
Yeah.
And that's it kind of brings us back to what we're doing with the program, which is bringing people to Mars
Right.
in a way that's authentic and engaging and like offers them a perspective on other planets that they can't access otherwise.
Yeah.
Right? Like there aren't any other simulations of the
Yeah.
surface of Mars that bring people into it to see what that's like.
Yeah. I can't remember what our next slide is.
I think that our next slides are also about the visuals.
Great. Oh, yeah.
This was another idea for
Uh-huh.
a business card, which Charlie brought up in yesterday's meeting.
Charlie,
And
come on stage.
Okay.
so we talked
Hey.
yesterday about.
Hi.
You mentioned in the all hands that you were interested in making
Closer,
some
closer. Stand up.
some business
off.
cards.
You're
No,
perfect.
you're great.
Okay,
Yeah.
thank you.
So I was looking at the design that Alex and Patrick were talking about and wondering if it could be adapted to something
Okay.
that's a business card shape,
Cool.
and then we could put the information on the back.
Yeah.
And since Charlie doesn't have a Discord account, he doesn't participate in our Discord conversations except when we share them on a laptop.
Oh wait, so if you like took those and like sandwiched them together,
One's
Yeah.
the front,
both
one's
sides.
the back.
Yeah.
Exactly.
Yeah. And Charlie, your introduction and the way that you joined the Mars Project
Yeah.
was kind of unusual. Do you remember what started it?
Oh yeah.
Oh, yeah. Can you just tell it as a story?
Well,
And step closer because the microphone works better when you're closer.
not a very good start.
No, it was a great start.
Yeah. I think
Yeah.
I think I drove a
Okay.
rover
That's
off the
gonna make a
table.
Yeah. What did you do?
I accidentally drove a rover off
Yep.
the table.
Yep.
Oh, yeah.
And what happened?
It broke.
Yep. And then what did you immediately turn around and offer to do?
Fix it.
And
Oh,
you
wait.
couldn't come back the next day.
Mm-hmm.
You couldn't come back the next day. And so on Monday of the next week, who shows up at Mars? Charlie.
Charlie,
Yes.
and we worked together. I think I cut some new pieces for you and showed them how they glue together.
Yeah.
And then you built it and you painted it with Daniel and you installed it onto the rover, and then Couscous was back up and running.
Yeah.
That was
Yeah.
awesome. And then
Yeah.
you've been coming to hang out ever since, which is super
Yeah.
fun.
Yeah.
Charlie has helped
Very
with the
helpful.
move, helped build everything.
Build manufacturing, put
Yeah.
together the sleds for Chabot.
Yeah.
Yeah.
Yep. So, let's see. Oh, the next thing I was going to do was introduce Aiden, because
Okay.
we sort of glossed over how Aiden got here. And I
Okay.
think there's two parts of that story that are really interesting.
Okay.
One is Aiden was in the summer camp program that, in the summer camp program where we debuted Mars,
Yes.
right?
Yeah.
As a camper.
Yep.
Yes.
And experienced us at our best and most chaotic.
Yeah.
Yes.
Yeah,
Yeah.
Were you part of the very pilot week too?
I was the pilot guy.
yeah. We were there was so much about that we didn't know
Yeah.
we didn't know,
Yeah.
right? And yet, his experience was so compelling.
Oh, it was amazing. I
He-
think, it was the very
he
jump
would
start.
not
Yeah.
stop bugging us.
Yeah.
Yeah.
And then the thing I'm very excited to share is Aiden is also the pilot of a new program called Gap Lab, which is our gap year for kids 16 and up, or gap half year in the case of Aiden. In that context of the gap year, he's been working on, every gap year student here has two responsibilities. They're an assistant in one of our band spaces, which is what we call a classroom, working with that age group, helping those kids have the best learning experience possible. And their second responsibility is their gap year project. And Aiden, tell us about your gap year project.
Yes, so my gap year project is what we've kind of coined the $10 rover. We learned with these rover sleds that we built for the exhibits is that so many people found them so interesting and found so many possibilities for things that they could do with them. So we gave her, kind of helped me create this idea of this $10 robot, this like folded cardboard rover sled that uses simple components and simple engineering to create like very unique experiences with rovers. And what we're trying to do is bring robotics and STEM engineering to all classrooms at an affordable cost, which they're not right now.
And where the rover isn't precious,
Yeah.
right? What we wanted to imagine was something where people would be perfectly happy to get out their paint and paint it.
We want kids to interact with it and make it their own, because the
Like
point is
hot
that you
glue.
exactly.
Yeah.
All you do is you just take off the shell and put on a new shell at the end of the year.
Yeah.
So one of the future programming offerings for Mars is that your classroom could do one of our one-off or series of
Mars missions.
and then your teacher could see that there's a lot of interest in the classroom and buy a set of $10 robots and bring them to school, and then as the students would have the same control functionality of their rovers at their classroom, so they'd be able to drive around and control it like a Burley rover. So instead of just having motors that go, it's actually controllable.
Right.
And then build off of it.
With
and
the exact same user interface that they learned on Mars, they can do it in the classroom.
Yeah.
Yeah. It's a fantastic project, and we'll devote probably a Mars vlog in coming weeks just to this project as we start to figure out and learn more about it, and we have a working prototype.
Yeah.
Yeah.
I think we should call it there.
Yeah, I think that's a pretty good point to wrap it up.
Yeah.
And if you would like to find us on other platforms and channels, if you have a classroom that would like to get notified when we're actually offering the Mars classroom experience, go to tinkeringschool.com/Mars and you'll find our sign-up sheet. You can mail us at mars@tinkeringschool.com, and our new program manager, just official as of this week, Naomi Hewen, will get your mail and answer any questions you have, and she is the master of our world, and it's been amazing already. Yeah. Sylvia runs an amazing channel called Burley Adventures that gives little glimpses behind the scenes and little milestones and things like that. On Instagram, you can find me on Instagram as well at @GaverTully, and I share a mixture of things happening at Brightworks, things happening at Tinkering School, things happening at Mars, and things happening on my ranch.
Yeah.
Yeah. Thank you all for tuning in, and we don't quite have a schedule for these, but
We'll see you next time.
see you next time.
Yeah.
Nice.